Yo dog, I heard you like networking. This bad boy right here is my HP microserver Gen 8 that was kindly sent as a donation to the channel. And it is going to be our test subject for this video. We are going to learn the ins and outs of Proxmox, VLANs, bridges, and bonds. Turning around our little star of the show here, we got 3 Ethernet cables in green. All of these are going to a managed gigabit switch. 2 go to the built-in Ethernet adapters. These are 1 gigabit. 1 goes to the lights out management, HP ILO. We're going to ignore that one for this video. So with these 2 interfaces, we can test out different styles of setting up the NICs, bridging them, bonding them, failover, link aggregation, LACP, all that kind of good stuff. And I heard you like multi-gig too. So I got a 2.5 gig USB 3 Ethernet adapter connecting up to the same switch. Between the dual 1 gig and the 2.5 gig, we can test bonding asymmetric connections, simulate what would happen if you had a 10 gig with a 1 gig failover, things like that. All of these are connected up to a switch. On the switch, I have another server connected with the full 10 gigs, so we can test iPerf across all of these different scenarios. So let's hop on over to the Proxmox web UI and get this bad boy configured. When you first set up your Proxmox system through the installer, you'll pick one interface and it will create a bridge in that interface. In my case, that interface was ENO1 and the bridge is VMBR0. All the other interfaces are disabled by default in the installer. So if we want to do anything fun with networking, we have to come to this place. So data center, name of your node, system, network. If I scroll over a bit, you'll notice that there's only an IP address assigned to the bridge, not to the individual ports. And that's very important. Once you take a port and you start assigning things to it, you're going to end up putting the IP address on the higher level device. So if I take 2 ports and I bond them, the IP address and the MAC address are now tied to the bond, not to the individual port. The individual ports don't have an address and they don't use their hardware MAC address, they use the MAC address of the bond and they share it. When we add a bridge on top of it, we again do the same thing. The bridge now has a MAC address and an IP address for the local system. So do the virtual machines that are attached to the bridge. And the hardware MAC address, and there is no hardware IP address, on the individual interfaces aren't used anymore, just the bridges. So if you want to change the IP address of your system, you need to change it here in the bridge. Of course, this depends on how you want to do your networking. And that's what we're here to talk about today. So assuming you're not in a cluster, and you're not using Ceph, there's a few different types of traffic you're going to see on Proxmox network. There's traffic to and from Proxmox itself. So that would be us visiting the web UI via the IP address of the Proxmox server itself. We have the Proxmox server going out to the internet for updates and connecting to remote storage via networks. Then we also have traffic which we're forwarding to virtual machines. So if you're using a firewall virtualized, you might be forwarding one interface directly to a virtual machine. So you don't want anything else to have access to that WAN interface. Or you might be putting everything on your LAN subnet and bridging it all to the same interface. And that's fine too. Maybe you have more than one interface. Maybe you have a 10 gig and a 1 gig and you want to bridge some VMs to the 1 gig and some VMs to the 10 gig. That's fine. And make more bridges. So basically you need to think about who is connecting to Proxmox with how much bandwidth, how am I connecting to my storages with how much bandwidth, and who are my virtual machines connecting to, again, with how much bandwidth. Then we can start to allocate what our network resources should look like. So the first and the easiest concept is the bridge. You can really think of a Linux bridge as a network switch. So here on the bridge we have bridge ports. Over here they're labeled slave ports. These are hardware ports that are connected to the bridge. So this would be like taking this network interface and plugging it into the switch. This network interface gets plugged into this switch. The other things we can plug into the switch are the node itself. So here we've assigned the bridge an IP address and gateway and all that good stuff. And that means that we're plugging our Proxmox server into that same switch. The third thing we can plug into that switch are virtual machines. So if I make a new virtual machine, when we get to the network tab, we can add a new network interface. And by default, it'll just add 1, but we can add more later. So I'll show you how to set this up. So first we can choose the bridge we want to connect it to. We usually want to use a para-virtualized interface if your software supports it. If it doesn't, you can use the E1000, that's a pretty good option. And the VLAN tag. So in this example, I could set it to VLAN 50. It'll automatically create a MAC address for the new VM. Good to go. So what this will do is this will plug in the virtual machine's net0 interface to the bridge VMBR0 and assign a VLAN tag of 50 to it. So this would be like using a managed switch and setting the PVID on the port to 50. We don't have to add a VLAN tag if we don't want to. We can always add more network devices here. So maybe we want to give it no VLAN as well. So now we have net0 and net1. One has a tag and one doesn't. We can add as many of these as we want. It'll pass them all through to the virtual machine. And one thing to be aware of is that this VLAN aware needs to be checked if you want to do that. It's a little nuance that you just got to watch out for. So when we set it to VLAN aware, that basically means that it's acting as a managed switch, which is aware of VLANs and lets us set the PVID on each port. And usually we want that to be the case. You can see we have pending changes here, and it'll tell you what the network configuration will look like if you're familiar with Linux networking. This will show up down here. So what if I want to directly connect two virtual machines together? Well, you have two options for that. The first option is to use an unused VM ID. If you're using a VM ID that's not used elsewhere in your network, you could just set this to something like 1000. And then on the other VM, you could also give it that same tag, and now the two of them can talk to each other. That does mean that that particular VM tag will be exposed on your interfaces here of the bridge. So if you're using that VM ID elsewhere in your network, you could have conflicts. The other way to do it is to create a new Linux bridge just to dedicate to binding the two VMs together, or 3 VMs, however many VMs you want. Now you can create a new bridge. In this case, we'll create it VMBR1, and we won't give it an IP address because the Proxmox system itself won't be able to communicate here. And we won't give it any bridge ports either because we're only using it for VMs. So we'll say go ahead with that. We'll apply that configuration. Now I can go to my test desktop and I can switch it over to VMBR1. And so now any VMs I add to this VMBR1 will be able to talk to each other, but not to anything else. So you can use this to create virtual networks if you're doing home lab networking, that kind of thing. And it's a very powerful feature. So now what about bonds? Bonds are useful when you either want to do failover or you want to do link aggregation. And the easiest setup for that is failover. So we're going to set up failover first. So I have ENO1 and ENO2. They're both gigabit Ethernet. And ENX with a long number. And this is USB, so it's going to have a long number. So what I want to do in this case is I want to use my 2.5 gig network and I want to failover to my 1 gig network. So let's create a new bond. First, we're going to go to this bridge, and we're going to get rid of the bridge port. And now we have unsaved changes, but we need to leave them unsaved, otherwise we're going to lose access. Now we're going to create a Linux bond. We're not going to give it an address because the bridge is going to give it an address. And our two slaves are going to be ENO1. And now we're going to type that long number out. ENX 0024278832FB. And our mode is going to be active backup. And the primary is going to be the 2.5 gig adapter, which is this one. Let's go. So now we have the bond created. And we can assign the bond, now bond 0, to the bridge. And that means that we'll take the two ports and aggregate them into a bond. The bond is using active backup mode with the 2.5 gig as primary. The bond is then assigned to the bridge, so all the traffic on the bridge shares the bond. And we can go. Apply that. Yes. Looks like everything still works. So if we want to see the status of the bond, we can do cat net bonding bond 0. So it tells me that link failed once because I was testing it earlier. We scroll up a bit. It says that's the currently active slave, which is good because that's our 2.5 gig NIC. So this doesn't require any special features on the network switch to implement failover bonding. All it does is it looks at the state of the link. Does it detect a cable or does it not? And as soon as it doesn't detect a cable, it'll instantly advertise its IP address and its MAC address on the other physical interface, the backup. So no need for managed switches that support LACP or link aggregation. This will always work. So with the 2.5 gig link up, I'm on iPerf 3. This normally isn't installed, but it's used for bandwidth testing. Iridium. So you can see we're getting very close to 2.5 gigabits per second. The bit rate will always be a little bit lower than the physical rate on the wire, because 2.5 gigabits refers to the actual number of bits on the wire, and you'll have a lower number because there's some bits used for synchronization, there's some bits used for the layer 2 MAC frames, and there's some more bits used for the layer 3 IP frames. So we're clearly able to get 2.5 gigabits. As soon as I take down the fast interface, so we fail back to the slow interface. So now we can see the interface is down. We're in iPerf 3 again, we should get about a gigabit. 958 megabits, 941 megabits, that's pretty good. That's about what we'd expect. Now what if we wanted to bond ENO1 and ENO2, and these are both identical. And these could be 1 gig interfaces, or they could both be 10 gig interfaces, or maybe something else. I found that reconfiguring the bond with the bond running didn't seem to work. I'm not sure why Proxmox wasn't reconfiguring it, but basically to switch this bond mode, I would switch the bridge to have no interface bound. I would delete the bond, and then I would assign the bridge back to a single interface. So let's say ENO1. Apply that, and then once it's applied, I would create the new bond again. So we're going to unassign ENO1. We create a new bond. Slaves are ENO1, ENO2. It is LACP, hash policy 3 and 4. Comment. Now that that's created, we can add the bond here and apply it. If you want to see how LACP is working, we can do that same trick to cat again. So cat proc net bonding bond 0, and we get a whole bunch of information this time. So starting from the top, it says LACP active is on. And so what that means is, so with LACP, at least one side of the link must be active. That means it is initiating the LACP bridge to the switch. In my case, by default, Proxmox is the active side. So the switch has to be configured to allow passive LACP. If the switch isn't allowing LACP, Linux can't configure it. So then it's got some more information. So there are 2 ports that make up the bond, and then there's a slave interface ENO1, which is 1000 megabits, a gigabit, and it says the 2 details, so the actor and the partner. So the actor is our side and the partner is the remote side. And the remote side is on port 24 and has this MAC address, so it's on port 24 of my switch, which makes sense. And the other slave interface is ENO2, and its partner is port 23, which makes sense because I have the 2 switch ports plugged in next to each other. So if your switch supports passive LACP, you shouldn't have to configure anything on the switch other than enabling that on the ports you're using. Now, I can't give you specifics on how to configure your switch, but I'll show you what mine looks like. So this is my CRS328. It's running SwitchOS. I go over to lag. By default, I have them all set to passive, so if someone were to plug in an LACP device to random ports around my house, it would work. Not that you would necessarily want to do that, but it would work. And then again down here, ports 23 and 24 found a partner. The partner is CE, CD, E0, ... which is our Proxmox system. And they are on trunk 1, so that means they're the first LACP group on the switch. So even though we now have 2 gigs aggregated with LACP, we still can't get more than 1 gigabit per second per session, because it's taking the hash of the header information to determine which interface to send a packet to. And if the packets are all going from the same source to the same destination, they'll all have the same hash. So if I run iPerf again, I'm still just going to get about 950 megabits per second. 947, 938, about what I'd expect. So I install iPerf on a virtual machine, So this is running on the Proxmox system, so it's sharing the networking from Proxmox. And if I run this with the same command, it's again getting 950 megabits per second. So now I'm able to get the full gigabit from the VM and separately from Proxmox. I'm doing this by running iPerf in reverse. And that means that because I have one iPerf server, all of the packets are destined for the same MAC address, the same IP address, and they're not getting spread out across the interfaces. When I run in reverse, the packets are destined for the two different clients. So if I run this one in reverse and I run this one in reverse, you can see they're both going to get the full bit rate at the same time. So that one's getting about 950, this one's getting about 930. So they're spreading across the two links in one direction. So because we have three interfaces, we could bond to bond. So what if we have, say, a dual 10 gig card we usually want to bond, and we also have two 1 gig interfaces we like to fail back on? Then we can bond to bond. In my case, I only have three interfaces. So I'm going to have my LACP bond as bond 0. I'm going to create a new bond that has my 10 gig. I'm going to bond that with the LACP, and then we'll fail over from the single 10 gig back to the dual 1 gig. So we're going to, again, remove the bridge port so that the thing becomes free. Create a new Linux bond. Our slaves are going to be bond 0, and the giant name on my USB adapter, ENX0024278832FB. And we are going to use active backup. And that is our primary. So now we have 2.5 gig. That's our adding network card. And we're going to fail over to the two 1 gig network cards built into the motherboard. And then that new bond is going to become our main bond for the bridge. Let's apply that. So let's see what we see in bonds. So we see two bonds again. We can cap both of them. So bond 0 is our dual 1 gigs, and it is up. They have found their partners, ports 23 and 24 on the switch. They are good. Now what if we cap bond 1? So we're reporting that the 2.5 gig is down. Maybe I left it down from earlier. Yeah, I did. Let's turn that back on. Yeah, I can just turn off switch ports on the switch management UI. There we go. So now it's up. So now our active slave is ENX. If I run iPerf now, I should get 2.5 gigs, and I do. And then if partway through this, I disable my bond port, it should fall back. Oh yeah, just at the end there. If I run it again, you'll see we've dropped down to 950 because we fail back from the 10 gig interface, or the 2.5 gig interface, to the dual 1 gigs. Now, there are other things you can do with your onboard NICs other than bond them like this. For example, if you're using a Proxmox cluster, the Proxmox cluster should have its own interface dedicated to clustering. And if you're using Ceph, Ceph would really like to have really high-speed storage for its private network. That doesn't mean you can't use VLANs to segregate Ceph if you want to segregate them for network management reasons. But you shouldn't be using VLANs to segregate the cluster traffic. You should give them dedicated interfaces. That said, CoreSync does not need much bandwidth, so having a 1 gig interface dedicated to CoreSync is perfectly fine. Even 100 megabits would probably be fine too. You don't need much. You just need something dedicated so that other traffic isn't affecting the latency of those packets for CoreSync. So hopefully I've shown you how to make the most of networking in Proxmox. One thing I didn't mention is Linux VLAN, and that's because it's very rarely used. It's much easier to set the bridge as VLAN enabled and tag individual VMs on specific VLANs. But what this doesn't let you do is set the Proxmox system itself onto a different VLAN. So if you need to VLAN tag the Proxmox system itself, that's where you could use Linux VLAN. So in this case, what we could do if we wanted to add a interface for Proxmox management on top of our bridge, we could say VMBR0 dot the VLAN number. So then it'll automatically fill in the VLAN raw device, which is VMBR0. It'll automatically fill in the VLAN tag, which is 100. Management. Then we would set up our IP address here for the Proxmox local system and remove that configuration from the bridge. Then our Proxmox local system would be accessing via VLAN 100. Normally you don't need to do this if you're using a VLAN aware bridge for your VMs. You would only need to do this if you have a specific reason to have a dedicated Linux interface, such as assigning the local Proxmox system IP address to the VLAN. So another possible use case for VLANs is that you might want to pass through VLANs to the VM. And by default, that just works. So I have an example here that's a router. It's a MikroTik CHR running RouterOS. And so I have just set up the network here to be on VMBR0 with no VLAN tag with the VirtIO interface. And that's important because some of these other ones don't support VLAN tagging. In RouterOS, I've added a VLAN tag 5. And I've tagged my test desktop onto VLAN 5 as well. I can come into the test desktop and see that it's getting an IP address in the correct scope, and I can ping the RouterOS's VLAN interface. So if you only want to let the VM access VLAN 1, or your default VLAN, you can put the VLAN tag as 1. So if I go in here and I set the VLAN tag as 1, now it's not going to let it access VLAN 5. So now the desktop virtual machine on VLAN 5 can't get an IP. So what if I want to give this VM access to some, but not all VLAN tags? Well, I can do that with the trunks command. So here's the documentation. It says trunks, VLAN ID, separated with semicolons. So to do that, we go here into the shell, and we need to edit the configuration file for the VM. And if you're on the system the VM is running on, in a cluster, or if there's no cluster, it'll be an etc pve local qemu server and then the vmid.conf. If you're on a cluster, it might be a slightly different path, but you'll figure that out. So we have net here. In this case, you can see this is basically the same configuration we have in the GUI. We have bridge, tag, and then we want to add trunk. So if I add the trunks command, I can add VLANs that the VM is allowed to tag. So I'm going to say 5 and 6, separated with semicolons. We'll save that, and if we go back here, it should show up here. So you would only use this trunks if you only want to give the VM access to specific VLAN IDs and make the VM do the VLAN tagging on its own. If you want to use a router, you can leave out the tag and leave out the trunks, and the VM will have access to all of the tagged traffic on the bridge, VMBR0, or whatever bridge you've assigned it to. I'm sure you've also noticed OVS here. This stands for Open vSwitch. So OVS is a little bit different in that it's for managing large-scale cluster networks using VXLAN, which is a much more complicated but much more feature-rich protocol than standard VLANs. So we're not going to deal with OVS today, but hopefully this video gave you a pretty good understanding of the Linux bridge, the Linux bond, and the Linux VLAN, and how to configure those in Proxmox and when you might need them. It's also important to remember that some of these bonding modes can still be used even if you don't have a managed switch. For example, the active backup or the balance round robin or XOR, all of these will work with a dumb switch. Active backup will work for anything. And then round robin and XOR, you'll end up where the traffic goes out on 2 ports but always comes back on 1 if the switch isn't managed. LACP is what you should be using if you have a managed switch that supports it, because you'll get balanced traffic from both sides automatically. If you have an older switch that doesn't support LACP, you could try to use balance RR or balance XOR and set a corresponding manual link aggregation profile on the switch side, but that's beyond the scope of this video. For most things with modern equipment, you should be using active backup or LACP. So thanks for coming along, everyone, on this Proxmox, VLANs, bridges, and bonds video. Hope you guys all had a great time. If you have any questions or comments, you can leave them down below. If you'd like to continue the conversation or suggest topics for future videos, you can find me on Discord. There's a link in the description for that. Always love talking about Proxmox and anything home lab or network related. And as always, see you on the next adventure. Boy howdy, do we have a topic to cover today, and it's networking. Yeehaw, time for networking in Proxmox. Yo dog, I heard you like networking. Which one of those is the least cringe?